Okay guys, let's discuss the JEE Main pattern exercises for probability. First question says there is a bag containing 10 white and 15 black balls. If two balls are drawn in succession without replacement, then the probability that the first is white and the second is black is what? So it's very simple. If you consider two events, A is drawing a white ball, in the first draw. Fine. And this is drawing a black ball in the second draw. You want to find out that in succession what is the probability that the first ball is white and second is black. You need to find the probability of A intersection B, right? What is this? We know this, multiplication theorems, right? Probability of A into probability of B by A. Probability of A means probability of drawing a white ball in the first draw. Right now in the bag you have 10 plus 15, 25 balls in total. Out of that you have 10 white balls. So clearly 10 by 25 is the probability of happening of event A. Multiplied by probability of happening of event B when A has already happened. That means probability of drawing a black ball in the second draw when one white ball has already been withdrawn in the first draw. Now when event A has already taken place, that means one white ball has already been withdrawn. That means now you are left with 24 balls in the bag. So total number of balls now left with you is 24. Right? Out of these 24 balls, you basically now need to understand what is the probability of event B taking place. Now all the 15 black balls are still kept intact. One white ball was basically withdrawn from the bag. So now you have 15 black balls and you have 9 white balls in the bag. So 15 by 24 is your very probability of B by A. When you find this number out, what you get is this becomes 1 by 4. So probability of A intersection B is actually 1 by 4. Clear? That is the probability that the first ball is white and second is black. Now moving on to the next question we have, it is given that the events A and B are such that probability of A is 1 by 4, probability of A by B is 1 by 2, B by A is 2 by 3, then what is probability of B? Okay, so over here if you can understand, you are given A by B's probability, B by A's probability. See, if I talk about probability of A intersection B, just now we did, it is probability of A into probability of B by A. Probability of A is given to me as 1 by 4 and probability of B by A is given to me as 2 by 3. So you basically get 1 by 6 as the answer. Now I am interested in probability of B. I know that probability of A by B is probability of A intersection B upon probability of B. Now probability of A by B is given to me as 1 by 2. Probability of A intersection B I just found to be 1 by 6 whole upon probability of B. So probability of B becomes what? 1 by 6 upon 1 by 2. 1 by 6 divided by 1 by 2 or multiplied by 2. And you get 1 by 3 as probability of event B. Okay, so probability of event B is 1 by 3. Easy enough. Moving on to the next, we have let A and B be two events such that probability of not happening of A union B is 1 by 6, probability of happening of A and B is 1 by 4 and probability of not happening of A is again 1 by 4. What is it about events A and B? Are they mutually exclusive as well as independent, or independent but not equally likely but not independent, equally likely and not mutually exclusive? So first of all, if you see, probability of A intersection B in the question is given to you as 1 by 4. Right? Probability of A intersection B is equal to 1 by 4, which is not equal to 0. That means A intersection B is not equal to phi, right? Therefore, A and B are not mutually exclusive. First of all, they are definitely not mutually exclusive, so A is wrong and D is wrong, because both of them are supporting the very mutual exclusiveness of events A and B. Now, I need to understand whether they are independent or not. For that, we need to show probability of A intersection B is equal to probability of A into probability of B. That is something that we need to show. Now, I am given probability of A union B whole bar is 1 by 6. Probability of not happening of A union B is same as 1 minus probability of happening of A union B. So, probability of A union B becomes 1 minus 1 by 6, which is 5 by 6. This is 5 by 6. That means probability of A plus probability of B minus probability of A intersection B is 5 by 6. Now, you are given that probability of not happening of event A is 1 by 4. That means probability of happening of event A will be 1 minus probability of not happening of event A. That is 1 minus 1 by 4, which is 3 by 4. Probability of B, I don't know. Probability of A intersection B is given to me as 1 by 4, and this is 5 by 6. Okay, so this becomes probability of A plus probability of B minus probability of A intersection B. 3 minus 1, that is 2 by 4, which is 1 by 2. So you get probability of B is 5 by 6 minus 1 by 2, which is 5 minus 3 by 6, which is 2 by 6, which is 1 by 3. And now if you can see probability of A into probability of B, probability of A is 3 by 4 into 1 by 3, that is 1 by 4, and probability of A intersection B is already given to you as 1 by 4. So, these both are actually equal to each other, which means that the events are independent. Now, they are independent and they are equally likely or not equally likely. So, see, probability of A is 3 by 4, probability of B is 1 by 3. Clearly, both the probabilities are not equal. That means the chances of occurrence of event A and B are not same, and therefore, they are not equally likely, but they are independent, and so option number B is the correct one. What does the next question say? Let's see. If A and B are independent events of a random experiment. So, the question already is giving you that they are independent. Probability of A intersection B is 1 by 6 and A bar intersection B bar's probability is 1 by 3. Then probability of A is equal to what? So, one thing if you can recall, if A and B are independent events, A bar and B bar are also independent events. We've proved that in the class. So, probability of A intersection B is given to me as 1 by 6. That is same as probability of A into probability of B, because they are independent events. I am saying let this be x, let this be y. So, you basically have x into y is 1 by 6. Now, the next thing is you are given that probability of A bar intersection B bar is 1 by 3. Now, again, if probability of A bar intersection B bar is 1 by 3, again A bar and B bar are independent events, so you get probability of A bar into probability of B bar is 1 by 3. Now, if probability of A is x, then probability of not happening of A is 1 minus x. Similarly, this is 1 minus y. So, you get 1 minus y minus x plus xy is 1 by 3. So, 1 minus x minus y plus 1 by 6 is 1 by 3. So, this becomes 1 by 3 minus 1 by 6, which is 1 by 6. Okay? So, therefore, you get what? That 1 minus 1 by 6 is x plus y. That is 5 by 6. So, you have x plus y is 5 by 6, x into y is 1 by 6. When you solve both these equations, you get x is 1 by 2, y is 1 by 3, or x is 1 by 3, y is 1 by 2. Okay. So that's what you get, and therefore x is my probability of A. So probability of A is either 1 by 2 or 1 by 3 depending upon the options given. So probability of A according to the options will be 1 by 3. Clear? Next question says that there is a bag which contains n plus 1 coins. So number of coins is given. It is known that one of these coins shows heads on both sides. So it's a biased coin which has head written on both the sides, whereas the other coins are fair. So out of n plus 1 coins, one coin is unfair because it has head written on both the sides, and rest of the n coins are fair coins. One coin is selected at random and tossed. If the probability that toss results in heads is 7 by 12, then what is the value of n? Okay, so if I define two events, that E1 is the event of selecting the coin with both heads. So both the faces have heads written, whereas E2 is selecting the coin or selecting the fair coin. What is the probability of event E1 taking place? There is only one coin which has both sides heads written, and there are n plus 1 in total coins. So probability of E1 will be 1 by n plus 1. Similarly, probability of E2 will be what? Out of the n plus 1 coins, n coins are fair coins and total number of coins is n plus 1. So n by n plus 1. Understood? Once you have this, question is probability that toss results in heads is 7 by 12. So if I take the event A as toss resulting in heads, you are given that probability of A is actually 7 by 12. But one thing you understand, toss can result in a head when you are tossing the coin which has both sides heads written, or when you are tossing the coin which is fair. So there are two sources for one event to take place, and therefore the concept of total probability pops up in here. And what do you get? Basically is according to total probability, probability of A is probability of the first source into probability of happening of event A from the first source plus probability of second source into probability of happening of event A from the second source. So probability of E1 is what? 1 by n plus 1. What is the probability that when you, basically probability of happening of event A when E1 has already taken place, means that what is the probability that you are going to get a head when you toss the coin which has both sides heads written? There is only one such coin, right? When you are going to toss it, there is only one possibility, head is only going to come because both the sides have heads. So this probability is 1. Probability of E2 we just found, it was n upon n plus 1. What is the probability of getting heads when you are tossing a fair coin? When you are tossing a fair coin, probability of getting heads is 1 by 2. Probability of getting tails is 1 by 2. Right? So what do you get? And what is this given to you as 7 by 12? So you get 7 by 12 is 1 by n plus 1 plus n upon twice of n plus 1. So clearly twice of n plus 1 you have. Here you have 2 plus n, and this is 7 by 12. When you resolve this, you very easily get n equals 5. So question was, what is the value of n? Answer is n equals 5. That's how beautifully the total probability concept pops in to help you get the answer. Now the next question says that the chances of defective screws in 3 boxes 1, 2 and 3 are these. One box is selected at random and a screw is drawn from it, and also it is given that the screw found is defective. If the screw is found defective, what is the probability that it came from box 1? Clear signal, you are already given the outcome that the screw is defective. Question is, what is the source from where it was withdrawn? And therefore, this is the very concept of Bayes' theorem, right? So you are given 3 boxes. So I am going to say E1 is selecting box 1, E2 is selecting box 2, and E3 is the event of selecting box 3. Probability of selection of box 1 is 1 by 3, which is same as selection of the second box, same as selection of the third box. Clear? 3 boxes? Fine. Now, what is the probability that you get a defective screw from the first box? See, if I say A is getting a defective screw, then what is the probability of getting a defective screw from the first box? It is given to you that getting a defective screw from box 1 is 1 by 5. Getting a defective screw from the second box is 1 by 6. And getting a defective screw from the third box is 1 by 7. Clear? Now, question is, what is the probability that box 1 is responsible for the defective screw that you have obtained when you have randomly picked up a screw from the boxes? So here basically we need to find out what is the probability that the source was E1 when A event has already taken place. What is the probability that when a defective screw has already been withdrawn, it has actually been withdrawn from box 1. This is nothing but Bayes' theorem. It is probability of E1 into probability of A by E1 whole upon probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3. You have everything which you need to plug in this formula. Each and every expression you have, all the values you already have. This answer basically is the answer that you need, that is probability of E1 by A, which is probability of getting the defective screw from box 1. Right, and that comes out to be 42 by 107. When you plug in all the values, in place of probability of E1, E2 and E3, you plug in 1 by 3, and in rest of the places you put this, you get 42 by 107 as the required probability. Clear? Next question says, if the probability distribution of a random variable x is this, then the value of k is what? Okay, let's see. If they are claiming that this is the probability distribution, first of all, if you remember, I had very cautiously asked you to note this, that the sum of the probabilities should give you 1. When you add all the probabilities, it should give you 1. If it is not giving you 1, then this is not a probability distribution. So if this is a probability distribution, sum of this is 1, and now the question is very easy for you. 1 by 10 plus 1 by 5 plus 3 by 10 gives you what? This becomes 2 by 10, I can write it as 2 by 10. So this becomes 1 plus 2, 3, 3 plus 3, 6 by 10. Plus k plus 2k, 3k, 3k plus k, 4k. This is 1. So what you get is, 4k is 1 minus 6 by 10, which is 4 by 10. Right? So k comes out to be 1 by 10. Clear? 1 by 10 is the right answer. So the only concept required here was that the very moment question is itself claiming it is a probability distribution, means that the sum of the respective probabilities has to be equal to unity. And that gives me the value of k. Next question says, again there is a random variable x which has the following probability distribution. So again, probability distribution is given to me. What is the mean and standard deviation of x? Okay, so let's see, we know how to do this. Xi and respective pi. So Xi is 1, 2, 3 and 4. Pi's are 0.1, 0.2, 0.3, 0.4. What do? We compute pi xi. This becomes 0.1, this becomes 0.4, this becomes 0.9 and this becomes 1.6. Then you compute pi xi square, right, and that gives you what? 0.1, then you have 0.8, then you have 2.7, and then you have 6.4. When you add this, what you get is 3, and when you add this, what you get is 10. Now you know what is the mean and standard deviation, right, of a probability distribution. What is it? Mean is summation pi xi. Summation pi xi we just found out it is 3, so mean is 3. What is the variance? Variance is summation pi xi square minus summation pi xi whole square. This we have evaluated the sum, this is coming out to be 10. Summation pi xi came out to be 3, 3 square is 9, so variance is 10 minus 9, that is 1, and standard deviation is nothing but square root of the variance, which is positive square root of 1, which is clearly 1. So mean is 3, standard deviation is 1, your answer is option number B. Clear? Next you have question number 9. If in a binomial distribution n is 4, probability of x equals 0 is 16 by 81, what is the probability that x is equal to 4? Let's see. So this is given to you. Let's see. Probability of x equals 0 is 16 by 81. What is this? N you know, n is 4, 4c 0, p to the power 0, q to the power 4 minus 0. So probability of getting success is small p and getting failure is small q. This is 16 by 81. So basically what you get is this becomes 1, this becomes 1, this becomes q to the power 4 is 4 by 3, or let me write 2 by 3 whole to the power 4. I can write it like this. 2 to the power 4 is 16, 3 to the power 4 is 81. So q comes out to be 2 by 3. P comes out to be 1 minus 2 by 3, which is 1 by 3. And now if you want to evaluate probability of x equals 4, this becomes 4c4, p to the power 4, p is what? 1 by 3. Q to the power 4 minus 4. This is again 1, this is 1, 1 by 3 to the power 4 is 1 by 81. So probability of x equals 4 is 1 by 81. Fine. Next question says that if the mean and variance of a binomial variate x for n equals 4 is 2 and 1 respectively, then what is the probability that x can take a value greater than 1? So n is 4, that means x can take values 0, 1, 2, 3 and 4. Mean is given to you and variance is given to you as 2 and 1. What is the mean of binomial distribution? NP. NP is given to you as 2. Variance is NPQ, that is given to you as 1. So if NP is 2, you get 2Q is 1. So Q is 1 by 2. So therefore P is also 1 by 2 because P plus Q is 1. Now you want to evaluate probability of x greater than 1. So if I am saying this is what I want to evaluate, this is same as 1 minus probability of x less than 1. Why? Because this is the probability distribution. So probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3 plus probability of x equals 4 is 1. I want to evaluate the probability of x equals 1 plus probability of x equals 2 plus equals 3 plus equals 4. So it is nothing but 1 minus probability of x equals 0. Right? Because x less than 1 is same as x equals 0. There is nothing more less than 1. So what is this? This is again 4c0, p to the power 0, q to the power 4 minus 0. Right? So this becomes 1 minus, so this is 1, this is 1, this is 16. So 1 by 16. So this becomes 15 by 16. So your probability is actually 15 by 16. So go through all the questions, practice nicely. That's it from my side. Thank you.